Here's a proof. This is from section, what, 4.4? Just so that people know. Section 4.4. And this is from the homework, and it's number, what, 6. So it's number 6. Okay. All right, so we've got everything drawn out. We've got what's given. We got what we want to prove. And first thing we do, let's go to red this time. Is that all right? Let's mark up the picture. That's what I like to do. All right? That's kind of fun, isn't it? So AB and ED are equal to each other. So where's AB? That one right there. And ED is that one right there. So we mark them equal. CA and CE, they're equal to each other. So I mark that, mark that. Now they actually marked them in the book for you, didn't they? They didn't have to, did they? We could have done that on our own. That wouldn't have been that bad. And what else do they tell us? This one, AC, line segment AC. Where's AC? This one right here. It bisects line segment BD. Well, look where BD is. BD is from here all the way to here. AC bisects that segment. So where does C hit? The middle. Okay, that's an okay way to say it. Or what's a better way to say it for geometry? The midpoint. Right, it hits it at the midpoint. So C is actually the midpoint, isn't it? All right. So what does that tell us about some of the sides here? You got it. That BC must equal what? Let's not call it CD though, because if I go from this outside to the midpoint, I'm going to go from the outside to the midpoint, okay? So BC is going to equal what? DC. Very good. Look at that. I'm basically done, aren't I? Do you see it? Do I have the triangles congruent to each other already? Absolutely. Okay, I was given two sides. That was easy. All right, and I had to figure out the third side. Now, the other proof that we just finished doing, which I didn't record, we found that third side by the reflexive property. But is BC and DC exactly the same line segment? Now, they're equal to each other in length. The measurement is the same, but they're not exactly the same line segment, are they? All right, so we can't say reflexive property, but look, AC bisects BD. So that means, what does it mean to bisect something? If we bisect either an angle or a segment or something like that, if we bisect something, what does it do? It doesn't just hit it in the middle. It doesn't just make two of them, two equal segments. That's right. It makes it into two equal segments. Does that make sense? And why do we know that? Why do we know that a bisector splits a segment into two equal segments?
Because God made it that way.
Because what? Because the definition, right, the definition of the bisector, okay? Because what does a bisector say? If you look back on it, it doesn't say it splits it in half. It never says that. It doesn't say it splits it in the middle. It never says that. It says that it splits it into two, what? Equal parts. Whether it's an angle bisector or a segment bisector, right? This one is not an angle bisector. What is it? It's a, what did I just say? It's a segment bisector, right? So it bisects a segment. So why does BC and DC, why do they equal each other? Because of the what? The definition, you got it, the definition of a bisector. You could just say bisector. If you want to be a little more specific, you could say the definition of a segment bisector, and that would be fine as well. Does that make sense? Who had their hand up? Somebody had their hand up. Did I answer your question? Okay. All right, so now let's do the little two-column dealie. Let's scooch this up just to give myself a little bit more room here. So we've got the two columns. Remember, every time, even in the book, it might say do a flow proof or a paragraph proof. We're just going to stick with two-column proofs, okay? Even though it might say, it really means the same thing. So we put statements and reasons. Statements, reasons. Let's do it a little quicker when we did the other one. Is that all right? Let's do this in white. What's the first thing you want to say? Again, you could try to get BC and DC equal to each other first if you wanted to. You don't have to. You could, though. What do we normally put first? The given. All right? Yeah, so we still have to say it, though. All right? We still have to say that they're equal to each other. All right? Because it's given. And then what else is given? That CA is congruent to CE. All right, and that's under the same reason. All right, we good so far, right? So what did we just find? Do you like doing this or not? No. This thing right here. This. Does that help? I think that helps a little bit. I like to do that. I came up with that on my own, okay? So I am very proud of that. Okay, so that's a side and a side. Where's my other side? Can I just go right to saying BC equals DC? No, because they don't tell me that BC equals DC, do they? What do you have to say? Yeah, that's right. You have to know that it bisected it before you said those two things were equal, correct? Because why were those two segments equal? They were equal because that segment BD was being bisected. So you have to say that first before you say BC equals DC. Do you get that part? All right, so you have to say that first. Now, that could have been in the very first step if you wanted it to be. But we did the given first, now we'll do this. So now we can say that AC bisects BD. And why does it bisect? Why does AC bisect? That's ugly bisect, but anyway, that says bisects. Okay, it's given, that's right. It's all given. All right, so if you want to write given 3 times, you can. If you just want to write given once and just call that one step, that would be fine as well. All right, doesn't matter. Now that we said that AC bisects BD, what did that tell us about that line segment? Caitlin, go ahead. Very good. And then that's what we can do right now. We can say that BC now is congruent to DC. Do you see how it's right underneath of this? Because it follows directly from this, doesn't it? It follows that AC bisects BD. So what do we know from that? We know from that BC and DC must be equal to each other. Yes?
I put BD is congruent to AE because
But that's not... BD probably... My guess is BD probably will be congruent to AE, but...
Well, because if ED and AB are the same...
If ED and AB are the same?
When it
Not necessarily, because this could be angled a little bit, and this could be, look, this AB could be angled here, and it could be angled here, and so it doesn't necessarily, because remember, we don't know this is a right angle. Looks like it, okay, and obviously looks like it, but we don't know it is. So you can't, and really that has nothing to do with our two triangles. AE's got nothing to do with this triangle and this triangle being congruent. Would you agree? So you want to kind of stay away from the extraneous stuff that really doesn't help us find what we're trying to find. I mean, there probably are other things that you could put in here, but it's not going to help you find what we're trying to find. You got it? Okay, so now let's do this. AC bisects BD, that means BC equals DC. Why do these two segments right here equal each other? Because of the bisector. Let's be a little more... That's right. Let's say definition. Use that word, definition. I'll just shorthand. I'll put DEF, right? Definition of... I'll tell you, I'm going to get real specific here. I'm going to say the definition of a segment bisector. Just so we don't get confused between an angle bisector. But if you just wanted to say definition of bisector, I'd be okay with that. I completely understand what you were saying. All right? Does that make sense? What did we just find by doing that? We got two sides already. We just found our third side. You got it. Everybody see that? Now, if you look above here, look what we have. I got a side, got a side, got a side. So what does that tell me about those two triangles then? Side, 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 and the triangles are what? Congruent. So let's write that down. So triangle ABC is going to be congruent to triangle EDC. And that's because of what? Side, side, side. And that's it. You're done. What do you think? It's not so bad, is it? Yeah. So really, I mean, the only really kind of hard thing maybe to understand is that when they told you that AC bisects this to make BC equal to DC, right? And then you just have to have a reason to back it up. And your reason is definition of a bisector. We good with that? They could have said EC bisects BD, couldn't they? Or they could have said something else. What else could they have told us? That C was what? The midpoint. That's right. They could have said C was the midpoint of BD. Then what would our reason be for BC equaling C or DC? Definition of midpoint. Right. You follow me? So they could have told you a couple different things. You just have to go with what they tell you. All right. Enough of that. Let's do another one. These are fun. I'm kind of getting into this, aren't you? Okay. Sorry. Nah, they'll always. I'm not going to put something on there you can't prove it. Right. It'll always be true. So whatever they tell you to prove, it will be true, and you should, be able to prove it. All right. Good question, though. All right. You want to do 12? Then we'll do 13. Is that all right?
Yeah.
We still have some time.
We have like 15 minutes.
Yep.
That's good. I like going there with time because it
Okay. Yeah, especially with these, and I definitely make sure that I make sure I give you some time to go over these because this is different. Gotcha. Yes. All right. There's our triangle. Let's put the given and prove over here. So the given, and let's label it. It's A, B, C, and D. All right. And it says that BD is perpendicular, whoa, to AC. All right. Well, as soon as I see that, my mind starts going, doesn't it? I start thinking what? Okay, BD is perpendicular to AC. Before I even write anything else down, what do you think might be true?
Isn't ADB a right angle?
Yep, this would be a right angle. This would be a right angle, okay? All right. And what do you think are true about any right angles? They're always what to each other? They're congruent. Very good. You got it. So we're thinking, aren't we? So BD, it also bisects. Okay, we're okay with that. We just did one with bisects, didn't we? Bisects AC. Look at that. BD bisects AC. So again, before you write anything else down, your mind should be rolling. It should be thinking. So if BD bisects AC, what else do you think you're going to say? AD equals CD. Yeah, you got it. And then now we're trying to prove. So let's prove that triangle ABD is congruent to triangle CBD. All right, good to go. Let's put our little 2-column dealies here and go from there. All right, let's use orange this time. Okay, let's mark the picture. BD is perpendicular to AC, so that means that is a right angle. Agreed? And that is a right angle if you want. If you want to put them both, you can. Make sense? So if they're both right angles, they're both what to each other? They're both equal to each other. That's right. All right, let's look at the next thing. BD bisects AC. Here's BD and it bisects AC. We've already mentioned that. Look at that. Bang, bang. Everybody good with that? That's all they tell you. Is that enough right there to say these triangles are congruent?
Yeah.
That in and of itself is enough? No. I got a side and I got an angle. I need another side, don't I? So am I going to go side, side, side on this one? No, because I don't know anything about AB and BC, do I? All right, I don't know that they're equal. And there's really no way from this information that I can tell that they're equal to each other. Agreed? So I got to look for something else. What's the other thing? It's one of those things, to me, it just is like right in front of my face. I see it. BD equals BD. You got it. Are you seeing that? Because look at the two triangles. They share something, don't they? What do they share? BD. They share that side BD. So BD on the left triangle is congruent to BD on the right triangle. You see it? Now look, I haven't written anything down here, have I? And I never want to until I've actually done this in my head. I want to go through it in my head, figure it out, then I can start writing all the stuff down. Okay? So that's where all the work is. It's inside your head looking to see why these triangles are congruent. Now, do you see why the triangles are congruent now? There's a side, there's a side. There's an angle, and there's a side. You see it? I got side, angle, side. Now, where's that angle, though? It's between those two equal sides. Everybody see that? All right, so the side has to be between the two equal sides. It wouldn't work if I said that angle A is equal to angle C. All right, the angle has to be between those two equal sides. All right. Okay, here we go. Statements and reasons, and now let's figure out what we're going to do. What's the... I said I was going to go side, angle, side, right? So I don't want to start with the angle. Even though the given, the first thing is the angle, you could if you wanted to. But for me, I kind of like to go in a nice order. I want to do side, then angle, then side. Is that all right with you? So let's start with this side right here, the AD thing. So can I come right out and say AD is equal to CD for my first step? No. What do I have to know before I say AD equals CD? I got to know the what? The BD bisects, exactly. So I'm going to use that as my first statement. Is that okay with you? So BD bisects AC. And that's given. All right, that was easy. But what follows from that? I don't want to jump to that, to the perpendicular thing. What follows right after this? If BD bisects, that's right, say it. You got it. Yep, AD is congruent to what? CD. Right. Okay, AD is now equal or congruent to CD. And what's the reason for that? It's not given. It's not given that AD equals CD. It's given that it bisects it. But what tells me? What allows me to say that if it's being bisected, it splits into two equal parts? The definition tells me that. Yep. So the definition of segment bisector. Okay? Do you understand why it's not given? It's not given. Look up here. Do you see it? Do you see anywhere where it says AD equals CD? No. But they give you this, but from that, you can figure out that AD and CD are equal. You got it? All right, let's keep going. So that's my what? That's my side. So that's one of my sides. What do I want to do next? I got a side. I want to go to the what? To the angle. Now, can I just say right away that those two angles are equal to each other? Nope. No, because nowhere up here does it say they're equal to each other, but it does say what about the angles? It doesn't. Do you see anywhere where it says it's 90 degrees? But it doesn't say it, though. Okay, you have to back it up. You got to back it up. So watch. So it says that BD is what? Perpendicular to AC. Now that's given, isn't it? Okay, so that's given. But what follows after that? If BD is perpendicular to AC, what does that mean then? They both have right angles, okay? Well, you can't say that. That's not what it means by... Now, it's true that it's true, right, that those two angles are equal, but that's not what perpendicular says. What does perpendicular say? Perpendicular says there are two lines that form two right angles. Look it up if you need to. Look up the definition of perpendicular. It says that perpendicular are two lines that form two right angles. So, that means what? That means angle ADB is what? What did I just say? What did I just say perpendicular said? Perpendicular says there are two lines that form what? Are two right angles, right? Okay, so ABD, actually, let's do this. Let's put them both in there. ABD and what else? Angle, if I go ADB, what would I do for this one? CDB. All right, go in the right order, okay? So A and C match up, right? So let's make sure everything matches up. So if I call this ADB, I'm going to call this angle right here CDB. All right? Are what? We don't know that they're equal to each other just yet. All right, but we do know that they're what? That they're, now the angles aren't perpendicular. Only lines are perpendicular, okay? So ABD and CDB are right what? Angles. What tells me that? What tells me if I have two lines that are perpendicular, they form two right angles? Yeah, see? She's catching on. Definition. We use definition over and over and over again to stuff, okay? If you don't know why, if you're in doubt, I would put the definition of something, okay? So it's the definition of, not right angles, okay? Perpendicular lines, right? It's a definition of perpendicular. Because what's the definition of a right angle? It's just that they're 90 degrees, right? It doesn't say that these two are right angles by the definition of right angles. It's the definition of two lines that are perpendicular. Okay, so it's definition of perpendicular lines. All right, so they're right angles. Have we said that they're equal to each other yet? No, we're not. Now, here's something you might have not gotten on your own, but I'll tell you right now. If both things are right angles, guess what? They're both going to be equal to each other, right? They're the same thing. If I say this angle is a right angle and that angle is a right angle, then guess what? They're equal to each other, all right? So angle ADB is equal to angle CDB. And my reasoning for that? This is kind of weird. They just kind of basically just repeat this. They say that here it is. Let's do this. All right angles are equal. And that's the reason. It's not really a definition. That's the reason. So write it down. It's not one that you might have thought of on your own, but that's the reason. So what did we just find right there? We got a side. Now we have what? Come on, talk to me. We have a side. Now we have what? We have two angles, right? We got angles. So what is this going to be then? This is going to be angle. So I'm going to put a little angle right here. All right? Yeah, but that's the easy side. Have we gone side angle side yet? Then we're not done. All right? Just because you've done 3 or 4 steps doesn't mean, okay, automatically we're done. You got to show a side, an angle, and a side. Okay, I've shown one side, right, equal to another side. Agreed? I've shown one angle equal to another angle. Now what do I have to show? The other side. And that's super easy. That's the easiest one. So how do I do the other side? That would be BD. Michael, tell me.
BD is equal to BD.
Yeah, BD equals BD because of reflexive property. That's right. So let's write that down. So BD equals, how does he know that? You're not astounded that he knows that, are you? Because we did that. We did that earlier. That BD equals BD because of reflexive property. Again, that's one of those easy, nice ones. Reflexive property is great because it's kind of easy to see because it's being shared by both of those, right? This side's being shared by both of those triangles, and we're good to go. So guess what's true now? Look, we got a side, we got an angle, we got another side. We've shown and we've backed up our reasons for all 3 of those things. So guess what we can say now? That the what? Anybody here? Not angle. You said angle? Oh, I thought you said angle. Yep. You got it. Okay? So those 2 triangles are equal to each other because of side, angle, side. Oh, I forgot to put my little side right there. See, I kind of like doing this little parentheses stuff, because I can see right in my proof. I got a side, I got an angle, I got another side. Does that make sense to you? It's just good organizational skills. That's all it is. All right? Side, angle, side. And there it is. I'm done. What do you say when you're done? QED, right. QED. Yeah, it's some Latin thing. All right? It's QED. It's like, I don't know exactly. It's like quid est demonstrandum or something like that, which means as was demonstrated, I think, is what I've remember. I might be off a little bit, but that's okay. Can we do one more? Do we have time? We don't? Let's try. Stop. Okay, I'm getting very disappointed here in you guys. You guys should be hungering for more. You shouldn't be. You should have a thirst for knowledge.
I'm full.
No, you're not. You're never full. That's the thing about knowledge, is you're never ever full. Did you know you have an unlimited hard drive for a brain? Okay? You have an unlimited capacity.
My brain doesn't.
You literally do have an unlimited capacity for your brain. Watch. Alright guys, you're being too silly. Let's pay attention now, okay? We've had our little jokes, had our little fun. You pretending like you don't want to do anymore, but I know you do. So watch. QS and PT. And we're trying to prove... Shh. I'm serious, guys. You need to settle down. I'm dead serious. Let's listen. Let's pay attention to me. You hear me talking, right? Like Mr. Dare said? If I'm talking, you shouldn't be talking. So let's write this stuff down. I'm serious. You writing it down?
I have it written down right here.
You keep looking away every time I look at you. That's why I'm staring at you, because you look away every single time. I'm waiting for you to pay attention and look up here and look at me. That's wonderful. But I want you to pay attention to me. With you having your head turned is not paying attention to me. That's what I'm concerned about right now. Here we go. Let's mark this thing real quick. I'll just stay in the same color. R is the midpoint of both of these segments, PT and QS. That means that this segment is equal to this. Why? It's a midpoint. So what tells me that a midpoint splits a segment into 2 equal segments? Definition of the midpoint. That's right. And it's also the midpoint of QS. So this one and this one are equal to each other as well. All right? That's the only thing they tell you. So I got a side and a side. Is there any way I can go this side and this side? Is there anything in here that tells me that PQ and ST are equal to each other? There's no way. There's nothing in here that I could say. But there is something. Look at something that we haven't used yet, but we have used in the past. I've got a side and I've got a side. I only have two choices. I got side, 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 and I figured I can't do that. So what's my other choice? Side what? Angle side. Is there any way that I can show those two angles equal to each other? Is there any way I can say this angle is equal to this angle? Emily? Okay, vertical angles are equal. Absolutely. Okay? So I know we're running out of time, but look what we're going to do. You can write this down on your own. I'm just kind of going through this mentally. Watch. PR equals TR. First of all, you got to say R is the midpoint of QS and PT. So then you can say that PR equals TR because of definition of midpoint. You can also say that QR equals SR because of definition of midpoint. Don't pack up, please. So QR equals SR because of definition of midpoint. All right, so far so good. And now you got your angle in here, don't you? So I could say angle PRQ is congruent to, I don't really care. Let's see. Boom, boom. Yeah, you can just say SR2. You can say TRS, whatever. So this angle is equal to this angle. So look what I have. I got a side, I've got an angle, and I've got a side. So the triangles are congruent because of side, angle, side. Right? Now, if you want to put it in a nice order, I would do QR equals SR, then I would do the vertical angles, right? And then I would say PR equals TR. All right, I think that might be a nice way to do that. Does it make sense? So you should be able to write all that stuff down. I told you what to write, and there you go. So I'm going to have you work on some of the problems I was going to give you on Friday, but I decided not to. So I want you to work on page, and add this to those proofs, okay? And there might have been, what, 1 or 2 proofs we didn't do today from last night's homework? If you completely got lost on those, try the ones that you didn't do, but add these to your list, okay? So this is still one homework assignment, okay? Don't turn this in and then turn the other. This is one homework assignment. So it's page 269, and I want you to do 24 to 26, okay? So 24, 25, and 26. So make sure that you finish up those other ones that we didn't get to today, and then these you want to just add to it. Okay, it's still the same section, but I want you to add these to it.